I hope you are getting well at home, safe and sound. So, welcome to our mathematics class. Today we are going to learn about the number line and Cartesian plane. This is 25th lesson in your textbook. Look at that. Page number 100. Take out your maths book and with a pencil, and also you have to take your notebook, and I hope you are ready to start the lesson. Okay children, look at that. By studying this lesson, you will be able to represent fractions and decimal numbers with one decimal place on a number line. Compare fractions and decimals using the number line. Represent on the number line the values that the unknown and inequality with one unknown can take. Identify a point on a coordinate plane by considering the x and y coordinates, and identify the nature of the coordinates of the points that lie on a line which is parallel to an axis of the coordinate plane. Okay children, now let's start the lesson. Look at this diagram. We can represent quantities by numbers. In maths, there are 3 books. Now you can see. So, we can represent this amount or quantity using numbers. That means you can use number 3 to represent that quantity. Then look at that. What is this? Those are pencils, color pencils. How many pencils are there? There are 10 pencils in here. So we can represent that pencils, that means that quantity, using that number 10. Look at that. There are 5 children in this picture. So this quantity also we can represent as number 5. Now you know how to represent quantities by numbers. Next, move on to the next slide. We can visualize numbers as distance. What is meaning of that? We know the ruler and measuring tape. Do you know the ruler and measuring tape? Yes, you know about that. So when we consider about that ruler, now there are numbers 0, 1, 2, 3, 4 like that. These numbers lie on a line. So we can say about that number line. Look at the measuring tape. Measuring tape also, there are so many numbers, but in equal intervals. The gap is equal. Those numbers also lie on the line. So those are the number lines. Okay children, now move on to the next slide. What is this? Where we can see the number lines? Look at that. There is a thermometer and shapes. Then water level. In day-to-day life, you can see that number lines in these places. Thermometer. When we consider about the thermometer, you can see the negative and positive numbers here. Negative and positive numbers. 0 also there. So, when we consider about the ship, there are numbers but only positive numbers. And also you can use these number lines for measure the water level in river. Now, next move on to the next slide. Why do we use a number line? To represent numbers, to compare numbers, and to add numbers, to subtract numbers. We can use for these number lines. Look at that number line. Now let's going to draw a number line. There is a number line, there is a line, so I mark this line, I separate this line into several parts, but in here these all parts unequal. Now I mention about the numbers in this number line. Now you can see 0, 1, 2, 3, 4, 5. The positive numbers, those are the positive numbers. In left side, -1, -2, -3, like that. Those are the negative numbers. So children, when we consider about the 0, now you can see red circle and look at the right side of this number line. Those are the positive integers. What is the meaning of positive integers? Integers means whole numbers. So positive whole numbers. Then look at that. When we consider about the left side from the 0, those are called negative integers. Negative integers means the negative whole numbers. -1, -2, like that. Next, move on to the next part. What is this? Yes, gap between two numbers is equal. Look at that diagram. The gap between 2 and 3 is equal, and also 0 and -1, the gap is equal. Now, we can get the conclusion. In a number line, all the class intervals between any two consecutive numbers are equal. What is the meaning of consecutive numbers? Consecutive number means close numbers. When we consider about 2, you can take the consecutive numbers 3 and 1. In right hand side you can take 3 and the left hand side you can take 1. Those are the consecutive numbers. Okay children, now we talk about the other part of the lesson. Okay children, now we are going to plot in that points on a number line. Look at that. In here, now we have to represent a equals 3 on a number line. So you have to mark like this, number 3, find the number 3, then mark a point, then you can write A. Then B equals -2. This is negative number. So you can mark like this, -2, B. C equals 0. 0 is the middle point on this number line. And D equal -5. -5 also negative integer. So you can find -5, then mark like this, and also you can write D. Then finally we have to mark E equal 4. 4 is positive integer, so you can mark like this, then you can write E like this. So children, now you know how to plot a point on a number line. Then move to the next part of the lesson. Representing fractions on a number line. Representing fractions on the number line. When we represent fraction on a number lines, there are two types. The first one is when the numerator are less than denominator. So when we consider about the fraction, there are two parts. What are they? The numerator and denominator. Numerator is upper one, denominator is lower one. When we consider about this half, numerator is equal to 1. Denominator is equal to 2. There are 5 fractions in this slide. Now we are going to represent fractions on a number line. Look at that. Now you can see a rectangle, yellow color rectangle. Can you see? Yes, this rectangle represents number 1. Now I want represent to half, that means 1 over 2. So how to represent that? You can divide this rectangle into 2 equal parts and you can shade one part. Then you can obtain 1 over 2 using that diagram. Then look at the other one, 3 over 4. The same rectangle in here, then divide into 4 parts, then I shade 3 parts. Then you can represent 3 over 4. Then third one, 2 over 5. How to represent that? Divide into 5 parts, then I shade 2 parts, then you can see, now represent 2 over 5. Finally, I take 5 over 7. The same rectangle divide into 7 parts and color 5 parts, then you can obtain 5 over 7. Then these numbers are lying between 0 and 1. So in here we can use numbers or fraction for these fractions because the fraction also are numbers. Then think about how do we plot these fractions on the number line? Look at that. There is a number line, but in here I mark minus 1, 0, 1. Then look at that. Now you can see red line between 0 and 1. When we consider about 1 over 2, you have to divide this gap into 2 parts because denominator is equal to 2. Then 3 over 4, you have to divide this gap into 4 parts. Now you know. The next one, what we have to do? Yes, divide this gap into 5 parts. Now you know how to separate this number line because all the fractions lie between 0 and 1. Now we have to represent this fraction on a number line. Okay children, hope you are ready. Look at that. 1 over 2, 0 and 1 here. The middle point is there. So you can represent like that, 1 over 2. Then 3 over 4. We separated this between 0 and 1 into 4 parts. Now you can see 1/4, 2/4. Then you can take the 3 over 4. The last one, 2 over 5. How to represent that? Separate between 0 and 1 to 5 parts. Then take 2 parts. Then you can represent 2 over 5. Now we discuss about the positive fractions. Let us see how to represent negative fractions on a number line. Look at that. Those are the negative fractions. Minus 2 over 3, minus 3 over 4, minus 1 over 2. Okay children, first one. Separate into 3 parts between 0 and minus 1 because the negative fractions belongs to between 0 and minus 1. In second one, minus 3 over 4. In here, you have to separate between 0 and minus part into 4 parts and take 3 parts from the right side. Then finally, you have to mark minus 1 over 2. Then this is easy one because you have to separate into only 2 parts. Then separate into 2 parts and take the middle point. Now you know how to represent negative fractions and also positive fraction. Now look at the other part of the lesson. What is this part? Look at that. When the numerator is greater than denominator. when the numerator is greater than denominator, 3 over 2. In here, 3 means numerator, 2 means denominator. So, 3 is greater than 2, isn't it? Yes, 3 is greater than 2. So, how to represent this improper fraction? This is called improper fraction. This improper fraction you have to convert into the another way. How to do that? Look at that. In here, 3 divided by 2, you can obtain 1 and remains 1. Then you can take 1 plus half. 9 over 4. 9 is the numerator, denominator 4. Then 9 divided by 4. There are 2 parts and also remain 1. Then 2 and 1 over 4. 18 over 5. 18 divided by 5. Then you can obtain 3 and remains 3. Then you can write 3 plus 3 over 5. So, these improper fractions you can convert into the mixed numbers. How to do that? Look at that. 3 over 2, 1 and half. The mixed number is a fraction with a whole number. So, 3 over 2 you can write as 1 and half. Now, look at the other one. Other part of this. Then 3 over 2, now you have to represent on a number line. Between 1 and half, lie on between 1 and 2. Like that. Then the other example. 3 and 1 over 4 and minus 3 and 1 over 4. There is a positive number and negative number. Look at that. First you have to draw a number line. Then take in between 3 and 4 and separate into that parts into 4 parts. Then you can mark this point like this. Then consider about the negative fraction. Minus 3 and 1 over 4. You can mark like this in left hand side on the number line. Now you know how to represent improper fractions on a number line. Then move to the other part of the lesson. What is this? Representing decimal numbers on a number line. Representing decimal numbers on a number line. 0.8, 1.4, minus 0.6 and minus 1.5. In here, the 0.8 means you have to separate in between 0 and 1 to 10 equal parts. Divide the length between two consecutive integers into 10 parts. Now you know the meaning of consecutive integers. So, we have to separate this whole number line into equal parts. Then you can obtain 0.8 between, lie on between 0 and 1. Then 1.4 in here between 1 and 2. Then negative 0.6 left hand side of number line, left hand side of 0, and also minus 1.5 lie on in here like that. Now you know how to represent decimal numbers on a number line. So, children, now we learned about fractions and decimal numbers represent on a number line. Now, move on to the next slide. Now, we are going to learn about increasing and decreasing words using that number line. Look at that. There is a number line. So, now you can see in blue color arrow. When we consider about the number line, now look at that. The value of numbers are increasing from left to right. the value of numbers are increasing to left to right. When we consider about the other way, now you can see the red arrow is going to left side. So, the value of the numbers from right to left are decreasing. Remember it. You have to, in a number line, the values of the numbers are increasing left to right, and the numbers decreasing, the value of the numbers are decreasing right to left. I hope you are clear to understand that. Okay children, now move to the next part of the lesson. What is this? Can you guess? Look at that. Inequality symbols. What are the inequality symbols? Greater than, less than, greater than or equal, less than or equal. Why we use these symbols in maths? Greater than and less than or greater than or equal you learn in grade 7 also. Greater than and less than we can use to compare the numbers. Consider about the not equal situation in maths. The 5 is equal to 5. But when we compare about 5 and 4, those are not equal. So, we can use the greater than and less than symbol for these situations. That means we have to use that symbols to compare the numbers. Okay, look at that one. There is a number line. Now I mark number 1 and then I mark number 4. Now you can see. So what is the greatest one? Yes, you know, the 4 is greatest one. So you can use that symbol 1 is less than 4. Or you can read 4 is greater than 1. Both are correct. Then when we compare about number 1 and number 2, now you know 1 is less than 2. The other one, 1 and 0, what is the greatest value? Yes, 1 is greater than 0. Then when we compare about 1 and negative number, 1 and minus 3, now you know the theory. The value of the numbers decreasing from right to left. Then you can put 1 is greater than minus 3. Finally, I mark number minus 5. Then you know 1 is greater than minus 5. Now we know how to compare the numbers, negative numbers and positive numbers. Look at that slide. There is a negative number. Now I am going to compare with a negative number, minus 2, and I mark number 4. It is positive number. So what is the greatest one? I am sure you know the answer. What is the answer? Minus 2 is less than 4. Minus 2 is less than 4. Then I mark number 2, positive number, minus 2 and plus 2. So what is the greatest one? Minus 2 is less than plus 2. Then minus 2 and 0. You know minus 2 is less than 0. These all the numbers are lie on the from right side from the minus 2. Then I mark -3. This point is lie on the left side from the -2. So, what is the greatest one? -2 is greatest value. So, you can use this symbol -2 is greater than -3. And -2 and -5, when we compare about these two numbers, you can take -2 is greater than -5. Okay children, now you know how to represent decimals fraction on a number line and how to compare the value of the numbers using inequality symbols. Now we are going to talk about the inequalities. So how to represent that inequalities on a number line? Look at that. Inequalities. X is greater than 2. So, you can take number 4, 6, 7 and 2/3 and decimal numbers also there. Now, you can take more than 2. The numbers, the values or more than 2. You can take as X. When we consider about the negative number with inequalities, X is less than -4. So, what are the values you can take for X? -5, -7. Look at this. In here, you can see numbers, decimal numbers and fractions. You can take all the numbers for this solution set because X equal to integers, X equal to fraction and also decimal numbers. Look at the other one. There is a special thing. X is greater than and equal -5. Now you know the values more than -5. You can take -4, -3 like this. And here when you write in the solution set, you should have to write -5 also, because X is equal to -5 and greater than -5. So, the similar one to the previous question, the X is less than and equal 7. In here also X equal to 7. So, when we are writing solution set, you have to write number 7. And now you know how to take the X values in inequalities. So, we have to represent the inequalities on a number line. So, how to do that? There is a question. Yes, look at that one. Represent inequalities on a number line. There are 2 points you have to consider about: type of solutions and boundary points. Type of solutions. What is this? Integral solutions and set of solutions. When we talk about the integral solution, you have to take the integers. This should be integers. When we take the set of solution, you can use integers, decimals, fraction, any number. This is the difference between these two. Look at that. Then also there is an open circle and closed circle. When we are doing examples, you can understand what is this. So, next move to the integral solutions. Integral solution means when we represent only the integers on the number line, that means X is greater than -1. This is the example. So, there is a number line. Now, we have to represent this inequality on the number line. You have to find -1. Then, X is not equal to -1. X is greater than -1. Now, first, you know what are the solutions of this. x is greater than minus 1 means you can take 0, 1, 2, 3, 4, 5. In here, we are talking about integral solution. Then you have to mark only that points. X is greater than minus 1. So, in here you can't represent any other fractions or decimals because they are about the integral solution, only integers. Remember it. Then look at that. X is less than and equal to. So, first you have to draw a number line. In here, x equal to and x less than 2. Then less than 2 means you can take 1, 0, minus 1 like this. And also you have to mark plus 2 here because x is equal to 2. So, x equal to 2 and less than 2. Then you can mark like this. Set of all solutions. What is this? The other part of this inequality. Set of all solutions. That means now in here you can write integers, fractions and decimals. So, when we take the examples, x is greater than minus 1. Now, you have to represent all the solution set on this number line. Look at that. First, I mark this minus 1. X is greater than minus 1. So, I mark minus 1 on this number line. Then, I mark right side of this number line starting from minus 1. In here, now you can remember the closed circle and open circle. In here, x is not equal to minus 1. So, we can't use closed circle because x is not equal to minus 1. Then you have to draw a open circle and color this right side of this number line. Why we are color this number line? Because I told you when we write the solution set means it including fractions, decimals, integers and all the numbers. You have to represent that value solution set in dark line. Look at the other example. Boundary points. That means open points. Boundary points, there are 2 points, open points and closed points. So, first we talk about open points, not shaded. Open point, not shaded. The number is not included in the solution. When we consider about x is greater than 3, you can't take the value of 3 for x. So, we mark number 3 using that open circle. Look at that. There is a number line. X is greater than 3. Then draw open circle in point 3. Then color the other solution set using dark line. The close point. Close point means x is equal and less than minus 1. Now consider that here x is equal to minus 1. Then you have to color this point. Then we can use close point for minus 1 and to represent the other numbers you can represent the left side because x is less than minus 1. So, the values are decreasing for right to left. Then you have to mark minus 1, minus 2 like that numbers. So, now you know how to represent fractions, decimal and inequalities. Now look at that. Mark the set of integral solution of following inequalities on the number line. X is greater than 1.5. So now you can do that easily because you know how to represent fractions and also inequality. Then combine with these two theories in this question. X is greater than 1.5, 1.5. They ask about the integral solutions. Then mark 2, 3, 4, 5 like these numbers. Only numbers. Then second one, x is less than and equal minus 2.5. The negative number, and here also x is equal to minus 2.5. But you can't represent 2.5 because they ask about the integral solution. Only integers you have to represent. Then you have to take minus 3, minus 4 and minus 5. Then next move to the other slide. Represent the set of solutions of following inequalities on number lines. X is greater than half. There is a number line. Now you have to represent the set of all solutions. That means you have to use the dark line. X is greater than half, then mark half and you can mark like this. X is less than and equal minus 2.5. First you have to draw the number line. Then mark minus 2.5 because in here there's about set of all solutions. Then you can use decimals and fractions also. Then mark this point and color that because x is equal to minus 2.5. Then draw the line like this. Next we are going to talking about combining inequalities. There are two inequalities. Now you have to combine these two. How to do that? Hope you are ready to do that example. Look at that. If the inequality has and x is greater than or equal minus 1 and x is less than 2. Now you can represent the first inequality on the number line. Now you know x is equal and greater than minus 1 and the second one x is less than 2. You can represent like this. Now we have to combine these inequalities. Combine this inequality means you have to connect this. Now look at this. There is a common part of these inequalities. So we can take the x values. When we are combining these two inequalities, you can take the common line. That means minus 1 is less than or equal x and less than 2. In here you have to consider about x is equal to minus 1. Then color this minus 1 point and use the open circle for plus 2. Closed circle for minus 1 and you have to use open circle for plus 2. Next we are going to talk about represent following inequalities on number line. Represent following inequalities on number line. Minus 2 less than x less than 3. Number line. So x is not equal to minus 2 and 3. Then you have to use open circles and it belongs to between these two numbers. The second one, minus 1 is greater than and equal x and equal and less than 4. Then draw a number line. In here x is equal to minus 1 and equal to plus 4. Now next move to the next example. We are moved to the next example. Minus 3 is less than x is less than and equal to. In here there is a number line also. Now you can see x is equal to plus 2 but not equal to minus 3. Then you can use open circle for minus 3 and closed circle for plus 2. Look at the other one. 0 is equal to x, 0 less than x is less than 3. Then now you know, first draw a number line. In here x is equal to 0, then mark this point using closed circle, but x is not equal to 3, then draw open circle for this point, then you can color like this. Then we are going to talk about if the inequality has O. We learnt about inequalities with AND. Now we are going to talk about inequalities with O. Look at that. X is less than minus 1, no, x is greater than 2. Now we have to represent on a number line that inequalities x is less than minus 1. Find minus 1, then draw open circle and you have to color the left side of from this minus 1. And the other one, x is greater than 2, then mark open circle in number 2 and color the right side of from number 2. In here the lines goes to the two ways. They are not combine each other. Then look at the other example. X is less than and equal minus 3. Now in here x equal to minus 3. Then you have to use closed circle for that. And also x is greater than and equal 0. There also you have to use for this 0 point. You have to color and draw lines like that. Then we are going to talk about a new theory, because we learned fractions, decimals, inequalities. So how to represent those things on the number line. So now we are going to do the next part of the lesson. The lesson is the number line and Cartesian plane. So the Cartesian plane is the other part of the lesson. Okay children, now look at the slide. Do you know that person? Who is this person? Yes, this person's name is René Descartes. This person, he is a philosopher and mathematician, and he found that Cartesian plane, the theory of the Cartesian plane. So now today we have to learn about that Cartesian plane. So I invite to find more details about that person. So now we are going to do the other part of the lesson, Cartesian plane. Look at that. Cartesian plane. This is a coordinate system that specifies each point uniquely in a plane by a pair of numerical coordinates. These coordinates are the assigned distance from the points to fixed perpendicular directed lines. There are two lines intersect each other and also perpendicular to each other. Then look at the other slide. Look at that. Each reference line is called a coordinate axis, or just x-axis and y-axis of the system. The point where they meet is its origin, usually at ordered pair 0, 0. In here there are two lines, x-axis and y-axis. So these two axes intersect each other. So intersection point we can call as origin. So, in here the coordinates of origin you can take 0, 0. The horizontal line of this Cartesian plane we can call x-axis. The vertical one is the y-axis. So, look at that. This example. Now, you can see a Cartesian plane. There are numbers with positive numbers and negative numbers. Now, I separate this Cartesian plane into 4 parts. Now, you can see in orange color there are positive region. When we consider about the x line, those are the positive, and also y axis also positive. So, positive region in this side. And then consider about the green color, there is a negative and positive, and also blue color region, negative and negative. Finally, I am talking about the pink color region. Those are the numbers line, negative numbers and positive numbers. So, we are going to study about that Cartesian plane. Look at that Cartesian plane. So, now we have to plot the numbers in here. Look at that point. Now, you can see a point 3, 2, A equal 3, 2. 3, 2 means ordered pair. Those are the coordinates of A. Now, in here you can give the location for this A, point A. That means first number 3 is represent x value and second number represent y value. So, you can write as a ordered pair 3, 2. Look, another one 2, 1. So, the first write the x value and then write the y value x2, y1. Then look at C equal -1 and 1. The left side of the Cartesian plane -1 and +1. So, x value -1, y value 1. Then capital D equal -2, 3. You can plot like this. -2 is x, the y value is +3. Then capital E equal -2 and -1. So, you can represent like this. Capital F equal -3 and -2. X and y all both are negative numbers. So, first -3 is a x value, then -2 is y value. Then capital G 1 and -2, 1 is the x value, -2 is the y value. Finally, H equal 3 -1, 3 is x value, -1 is y value. When we are plot the numbers or plot a point on a Cartesian plane, you can use ordered pairs. When we write the ordered pairs, first you have to write the x value, then write the y values. Look at that. Now, there is a line. Now, you can see the blue line and there are so many points on the line. When we take the ordered pairs of these points, now you can observe the x values and y values. In here always the x value equals to 2. So, we can give the special name for that, x equal 2. This line is called x equal 2 because always the x value is equal to 2. And also there is a special feature for that, the x equal to lines, x equal 1 or x equal 2 or x equal 10, these all lines are parallel to y-axis. Those lines parallel to y-axis. And look at another one. There is a line in blue color. Now you can see. Now I write the ordered pairs of the points of this line. Here -1 3, -1 2, -1 1. Then you can observe always x value is equal to -1. Now you know what is the name of this line. Yes, I know you know the answer. X equal -1. And here also, now you can observe here also this line parallel to y-axis. Look at the other one. Now there is a line but parallel to x-axis. So can you guess the name of this line? First we can write the ordered pairs -3 1, -2 1 like this. In here when we observe that, you can see the y values equal to 1. So you can write this name of this y equal 1 line. And look at the other one. This line also parallel to x-axis. Now I first write the ordered pairs. Now you can observe in here also y equal -3. Then what is the name of the line? Can you guess the name of the line? I think you know the answer. Yes, this is parallel to x-axis. So the name of the line starting from y because parallel to x-axis. So this y-axis cut from -3. Then it should be y equals -3. Then you have to write the coordinates. How to write the coordinates without Cartesian plane? Look at that question. Write the coordinates of 5 points which lie on the straight line given by x equal -3. First you have to write -3, then you can use any number for y value. The second one, write the coordinates of y 5 points which lie on the straight line given by y equal -1. The same way you can write ordered pairs in here, always y equal to -1. Then you can use any number for x values. 4 -1, 3 -1, 0 -1, -1 -1 and -2 or -1. Now next move to the next slide. Draw the straight lines given by x equal -3 and y equal -1 on the same Cartesian plane. Now you know how to draw that line, x equal -3 and y equals -1. So these two lines are intersect. Now you can name this intersection point because you know how to write the ordered pairs. Now you can do exercise in this lesson. Today we learnt about fractions, decimals and inequalities, and also those numbers, how to represent on a number line, and also we learnt about the Cartesian plane. So hope you enjoy the lesson very well, and hope you have to do more exercise, and do you remember you have to observe, or you can find more details about that mathematicians. So remember it, and